Hello everyone, my name is Alia Yasmin and my student ID number is 2023-30281. In this video, I'm going to present my deep learning practicum on LNN for regression and classification. Through the experiment, we will see how simple neural network can learn both linear and non-linear patterns from data. Let's start with the first part. In this code, I first import several libraries, pandas and numpy for data processing, keras for building the neural network, and matplotlib for visualization. I generate random value for x between 0 and 10, then calculate y using a linear equation y, 3x plus 2 plus a small random noise. This stimulates a real-world data that's not perfectly linear. The scatter plot shows the blue forming a roughly straight line, which represents a synthetic linear regression dataset. And next, in this part, I create sequential neural network with only one neuron in dense layer. I compile the model using SGD and MSE as the loss function. Then I train the model for 100 epoch. After training, the model learns the best weight and bias value. In my output, the weight is approximately 2.92 and the bias is 2.20, which is very close to the original equation. The plots show the real data as blue points and the model's prediction as a red line. As you can see, the red line fits the data almost perfectly, showing that our linear LNN successfully learned the underlying. Next, in this section, I switch from regression to classification. I use make moons from scikit-learn to generate a nonlinear dataset shaped like two interlocking half moons. The dataset contains 100 sample divided into two classes, represented by red and blue dots. Then I split the data into 50% training and 50% testing set. The scatter plots show two curve clusters that overlap slightly. This type of data often used to test how well a model can handle nonlinear boundaries, which is challenging for a simple linear neural network. And here I define a new LNN for classification. It has only one neuron with a segment activation, which converts outputs into probability between 0 and 1. The model is compiled with the Adam optimizer, the binary cross entropy, loss, and accuracy as the evaluation metric. After training the model for 100 epoch, the accuracy was around 54%. This result shows that a linear model cannot properly separate the moon-shaped data because the dataset is nonlinear. It requires a deeper network or nonlinear activation to perform well. To conclude, this practicum demonstrates the fundamental difference between linear regression and classification using neural networks. The LNN for regression worked very well because the data was linear. However, for the moon classification dataset, the accuracy was low because a linear model cannot capture complex nonlinear patterns. This experiment highlights why deeper architecture like multi-layer neural network are essential for solving more complex problems in deep learning. Thank you for watching my video.